Hello everyone, this is Pulcharla Maheshwar Reddy. I am currently pursuing my BTech in ECE department at SRIT. Today I would like to do a video presentation on the core signal system and static process. And the topic is exponential Fourier series, derivation and expressions. Exponential Fourier series, derivation and expressions. Statement: exponential Fourier series. Statement: it is a periodic signal is represented by a linear combination of a complex exponential orthogonal signals that is known as exponential Fourier series. The exponential Fourier series signal x of t is x of t tends to t, where t less than t naught less than t less than t naught plus t. It is also represented as x of t equals to summation n equals to minus infinity to plus infinity c suffix n into e power j n omega naught t, and this equation is considered as equation 1, where cn is an exponential Fourier series coefficient. Omega naught equals to 2 pi by t is also known as fundamental frequency. N omega naught equals to nth harmonic frequency. Evaluation of Cn. The approximation for the nth term can be given as x of t is similar to c suffix n into e power jn omega naught t. Cn is represented as equals to integral t naught integral t to t naught to t plus t x of t into e power jn omega naught t whole star into dt by integral t naught to t naught plus t modulus of e power jn omega naught t whole square into dt. It is also represented as, if e power anything star means it will become as minus 1. So x of t integral t naught to t naught plus t x of t into e power minus jn omega naught t into dt by integral t naught to t naught t plus t, so 1 into dt. It is also represented as Cn equals to 1 by t integral t naught to t naught 2 plus t x of t into e power minus jn omega naught t into dt. The relation between trigonometric Fourier series coefficient with exponential Fourier series. Consider the exponential Fourier series as x of t equals to summation n equals to minus infinity to infinity c suffix n into e power jn omega naught t is equation 1. Splitting the summation as x of t equals to c naught plus summation n equals to infinity to minus 1 c suffix n into e power jn omega naught t plus summation n equals to 1 to infinity c suffix n into e power jn omega naught t. In the above middle term of the equation, put n equals to minus n. So x of t equals to c naught plus summation n equals to 1 to infinity c suffix n into e power minus jn omega naught t plus summation n equals to 1 to minus plus infinity c suffix n into e power jn omega naught t is also c naught equals c naught plus summation n equals to 1 to infinity c suffix n e power jn omega naught t plus c suffix minus n into e power minus jn omega naught t. So x of t equals to c naught plus summation n equals to 1 to infinity cn plus c suffix minus n into cos n omega naught t plus j into c suffix n minus c suffix minus n into sin n omega naught t, considered as equation 2. We know that trigonometric Fourier series is given by x of t equals to a naught plus summation n equals to 1 to infinity an into cos n omega naught t plus bn into sin n omega naught t is considered as equation 3. By comparing equations 2 and 3, a naught equals to c naught, an equals to cn plus c suffix minus n, bn equals to j into c suffix n minus c suffix minus n is also c naught equals to a naught, cn equals to 1 by 2 into an minus j bn, C suffix minus n equals to 1 by 2 an plus j bn. Cosine for Fourier series. Cosine form for Fourier series. The cosine form for Fourier series is given by x of t equals to a naught plus summation n equals to 1 to infinity an cos into n omega naught t plus tn, where a naught equals to an and capital An equals to square root of an square plus bn square, and tn equals to minus tan inverse of bn by an. We will do a problem related to exponential Fourier series. Compute the exponential Fourier series for the following signal. Here they given the signal and periodic signal for f of t equals to t, period of signal f of t equals to 4, omega naught equals to 2 pi by t. So here capital T is 4. So 2 pi by 4 will cancel out, we will get pi by 2. Fn equals to 1. Yes, exponential Fourier series. F of t equals to summation n equals to minus infinity to infinity f of n into e power jn omega naught t. Here f naught equals to 1 by t into 0 to t f of t into dt. Equals to 1 by 4 into integral 0 to 1 into 2 into dt plus integral 1 to 2 1 into dt plus integral 2 to 4 into 0 to dt. F naught equals to 1 by 4 into 2 plus, after substituting the limits we will get f naught equals to 1 by 4 into 2 plus 1 divided by 4 equals to 3 by 4. Similarly for Fn equals to 1 by t into integral 0 to t f of t into e power minus jn omega naught t into dt. Fn equals to, after Fn equals to 1 by 4 into integral 0 to 1 2 into e power minus jn pi by 2 in t into dt plus 1 integral 1 to 2 e power minus jn pi by 2 into t. Here we will see formula equals to integral e power at into dt equals to e power at by a. Similarly f of n equals to 1 by 4. After substituting that formula on the above equation, 1 by 4 into 2 by minus jn pi by 2 into e power minus jn pi by 2 into t. Limits 0 to 1 plus 1 by minus jn pi by 2 into e power minus jn pi by 2 t. Integral 1 to 2. Fn equals to minus 1 by jn by pi into, after substituting the limits we will get this one, minus e power minus jn pi by 2 minus 1 minus 1 by 2 jn pi into e power minus jn pi minus e power minus jn pi by 2. Fn equals to 1 by jn by pi into 1 minus e power minus jn pi by 2 minus 1 by 2 into e power minus jn pi plus 1 by 2 e power minus jn pi by 2. Fn equals to 1 by jn by pi into 1 minus 1 by 2 into e power minus jn pi by 2 minus 1 by 2 minus 1 whole power n. So f of t equals to summation n equals to minus infinity to infinity 1 by jn by pi into 1 minus 1 by 2 e power minus jn pi by 2 minus 1 by 2 minus 1 whole power omega into e power minus jn omega naught t. And thank you.